to account should be taken of both international and national regulations in the considered application area. So when you have to, like, when you determine the risk-based analysis, you have to keep in mind that and follow the international and as well as the national regulations in the area of the application where your risk-based analysis should be done. However, for risk analysis performed for decision making in the private or intercompany sphere with no potential consequences for personal or third parties, the criteria may be established without taking account of such regulations. So in some private or some intercompany organizations, while determining the risk analysis, the regulations, like you may not take the regulations from international and national regulations, because keeping in mind that there is no potential loss or consequence or results for the persons involved or for the third parties. So the criteria may be changed when it comes to the private or intercompany sphere organization. Next is risk assessment. The risk assessment process is merely a comparison of the estimated risk with the accepted risk, initially stated in the risk acceptance criteria. So, in the risk assessment, the risk contributions to the different criteria may be presented in terms of critical risk scenarios, components, and subsystems. So, different criteria in the risk assessment includes critical risk scenarios, components, and subsystems. Furthermore, the results of the sensitivity analysis may be included as a guideline on possible measures to be taken for the reduction or control of risk should they not be acceptable. So when we determine the results for sensitivity analysis, we can include or we may include the guidelines, the measures that are to be taken for the reduction of the risk or control of the risk. Next is risk treatment. Should the risk not be acceptable in accordance with the specified risk acceptance criteria, in principle, 4 different approaches can be made, namely, so in risk treatment, 4 approaches are made, that is risk mitigation, risk reduction, risk transfer, and risk acceptance. So the first one is risk mitigation. In essence, risk mitigation is implemented by reducing the probability of the occurrence of the hazard scenario to 0. Risk mitigation means occurrence of hazard scenario should be reduced to 0. So in practice, by modification of the system, and how this hazard scenario can be made to 0 by the practice or by the modification of the system. The risk of corrosion damages in concrete structures may, example, be mitigated by the use of non-corrosive reinforcement. So the example I've given here is the use of corrosion damages that takes place in the concrete structures. So this may be mitigated to 0 by the use of non-corrosive reinforcement. Next is risk reduction. It may be implemented by reduction of the consequences or on the probability. So in practice, risk reduction is normally performed by a physical modification of the considered system. So how is risk reduced? By physical modification of the system that we are considering for risk. So considering the risk of fatigue failures in welded joints, this might be reduced by increasing the requirements for quality control of the performed welds. Okay. Next is risk transfer. It may be performed by example, insurance or other financial arrangements where a third party takes over the risk. So risk transfer means by transferring the risk to a third party. This third party may be insurance or other financial arrangements. Therefore, risk transfer is normally associated with a cost. Risk transfer is associated with it's related to a cost. Risk not related to cost consequences are normally non-transferable. So definitely the risks which are not related to cost are non-transferable. Next is risk acceptance. As a last option, if the risks do not comply with the risk acceptance criteria and if other approaches for risk treatment are not effective, risk acceptance may be an option. So at the last one is if there is no other any option, like even after doing the risk treatment or risk control and this does not turn out to be effective, then we have to go for the risk acceptance, which is the last option. This may example be the case when considering unacceptable economic risk and where the cost of risk mitigation or risk reduction or transfer higher than the desired risk reduction. So example here it is, like sometimes unacceptable economic risk may take place. In such unacceptable economic risk, it includes the cost of risk mitigation or risk reduction or transfer, and these costs are higher than the desired risk reduction which has to be done. So risk acceptance may normally not be pursued when risks to personnel are considered, and if so, usually only for limited periods of time. So generally people don't go for risk acceptance, rather people always think of doing the risk mitigation and control. But if there is no any other option, then the last one that is accepted is for risk acceptance, depending for only a limited period of time. Next is risk monitoring and review. Risk analysis may be performed as already stated for a number of decision support purposes we have already mentioned. So for many engineering applications such as monitoring of the safety of offshore oil production platforms, cost control during large construction projects, and inspection and maintenance planning for building structures, risk analysis is a living process involving a constant feedback of information from the considered system to the risk analysis. So here, what happens is that we have to consider engineering for in different engineering application, which may be monitoring of the safety of offshore oil production or platforms, then cost control during large construction project, inspection and maintenance planning for bridge structures. Here we have to see that risk analysis, it is a constant living process, that is a constant ongoing process which involves also a constant feedback. This feedback should be considered from the starting of the system to the end of the risk analysis. So whenever new information is obtained, the risk analysis may be updated, and in this manner, it is used as a vehicle for optimizing the system performance in regard to the specified acceptance criteria. So when you get any new information during the analysis procedure, this needs to be updated, and in this manner, we can use as a vehicle of optimizing the system performance in relation to the acceptance criteria. Next is detailing of risk analysis. So risk analysis, as shall be seen, might be performed at various levels of detail. So risk analysis is performed at different levels of detail, as we have seen earlier in the figure. So therefore, for the purpose of communicating the results of a risk analysis, it is important that the degree of detailing used for the analysis is indicated together with the analysis results. 1 minute. So, when in the purpose of communicating the results of a risk analysis, it is very much important when the degree of detailing that is used for the analysis is indicated together with the analysis results. Otherwise, what happens? The decision maker who uses or who bases his decision making on the result of the risk analysis has no other alternative or ways for assessing the quality of the decision basis. So no general agreement has been established in this regard so far, but in the nuclear industry, the following categorization has been agreed for so-called probabilistic risk analysis, which is PRA, or probabilistic safety analysis, which is PSA. So till now, there is no any general agreement that has been like incorporated or formed, but in the nuclear industry, there are categorizations. And these categorizations are called as probabilistic risk analysis PRA or probabilistic safety analysis, which is PSA. So their analysis includes level 1, which is analysis of the probability of occurrence of certain critical events in a nuclear power plant. The first level is analyzing the occurrence of critical events in a power plant. Level 2 is analysis of the probability of occurrence and the consequences of certain critical events in a nuclear power plant, which is the same thing again. And the third one is as for level 2, but in addition, including the effect of humans and the loss of human lives when this might occur. Level 3 includes the probability or analysis of occurrence for the humans, loss of human lives which might occur while the nuclear test has been done. So whether this classification is also useful for other application areas, it can be discussed. But the idea of classifying the levels of risk analysis under any circumstances is a